Today we have to do some sort of Java programming. Repeat again, boys and girls. We have finished the first chapter called as Boolean algebra. A sizable number of problems have been solved from past ISC question papers. And second one is second chapter, which is computer hardware, right? Where we have seen various gates, applications of gates, adders, encoders and decoders, right? Now, what we need to do is we need to do Java programming, for which we have been revising what has been done in class 11, right? Other day we did 3 programs. Today, let me make an attempt to do another 3 more programs. I repeat again, a huge responsibility on your shoulders, boys and girls. We don't have a direct contact with one another. It's your subject. You have to give your ISC examination. I wish and hope you practice the programming. Take a notebook, keep practicing it, get it typed on your computer system, compile it and execute it. I'm sure you will get the output, right? Today I have written 2 programs, rather 2 questions on the board. Here, write a program in Java to input 2 numbers and find greatest common divisor of given 2 numbers and least common multiple of given 2 numbers. We have to call this as GCD, greatest common divisor. So 2 numbers we need to input. So to input, what happens is we can send some values from main method. What I am going to do is I am going to write 2 programs. Should I write 2 programs or 1 program? I think we shall write only 1 program with the 3 methods. Write a main method where input the value of A and B, send the 2 numbers. This, write a method called as GCD. This method will find the GCD and display it. Right? The next one is input 2 numbers, right? Find their LCM and return it back, right? This is what exactly I am going to do. What is the first method is? The first method is GCD. The second method is LCM. What I want to know is, no matter wherever your main method is there, okay, that will be executed first, immaterial of its presence. Possibly your main method could be the first method of your class, the main method could be at the mid of the program, or the main method could be the rock bottom of your program. As I told you before, your main method is the gateway of your program or entry point, right? Here, because I need to input 2 values, namely x and y or a and b. So which I wanted to take from the keyboard, right? So I am using one of the packages which I wanted to input. So what I wanted to give the class name as program. What is the method to be? What your comment or remark would be? Program to find greatest common divisor and least common multiple. Is this clear, boys and girls? This is what we intend to do. Now, the next one is input statement. As all of you must be aware, I am going to import java.utilities.scanner. When you say scanner, you are going to import only the scanner class. Otherwise, if I if I put asterisks, what happens is all the classes under this utilities package will be loaded into the RAM. What we want to do in the first job is what? We have to find out the GCD of two numbers. We have to find the GCD of two numbers. Now let me give the class name. What do you want to give the class name as? What do you want to give the class name as? Where you are going to find out the LCM, you are going to find out the GCD, right? Which one do you want to do it? Should I say this? By the way, boys and girls, GCD or HCF, highest common factor or greatest, HCF or greatest common divisor, both are one and the same, right? HCF or GCD is one and the same. What I want to do is, I give the class name as what? LCM underscore GCD. This underscore and dollar, only two symbols are allowed, right? Here I use a underscore. Now what I want to do is, I am going to divide, my planning goes like see, whenever you write a program, even council recommends, you divide the programming skill into two. The first one is called as planning session. The second part is known as practical session. So before we start writing the program, some thought process has to go like this. What do we require? What all the inputs are required? What is our intentions? How do we calculate? So this algorithm, okay, has to be systematic. Now what I want to do is, I wanted to divide my entire class into three. The first module will have, let's say, GCD. The second module will have LCM. The third module where I am going to input and send it across two numbers. Is this clear? Is this clear, boys and girls? Should I repeat? I am going to divide this program into three. Otherwise, you can begin, very customary way of doing is, you can begin the main method from there also you can do it. There is no hard and fast rule that the main method need to be right on top, need not to be. What I want to do is, I need to create an object, because this is where I am going to take two values, A and B. To do so, what I need to do is, I have imported this scanner class, so let us create an object, right? This is the class name, any object name, let's say INPIQ, input search form, new. What do I do is, I create an object called as INP. With the help of this INP, I have to input two numbers. Okay, let's say both the numbers happen to be N1 and N2. Both of them are integer numbers. The moment they are integer numbers, let me input them. Why do I give this? If I do not give this, Because it's an integer, what I need to do is look at here, boys and girls. What do I do? I create an object called as INP. With the help of the INP, I use this method to input an integer number which will be stored in N1. Similarly, where I is an capital letter, right? I take the value, I key in the value, okay, from the keyboard as an integer that will be stored in N2. So both the numbers are there. These values I send it across to a method called as GCD or HCF, where it finds a greatest common divisor. It will display the answer. Then followed by your LCM. Right? So what do I do is here. Result 1 is equal to, okay, this is called as method call. Please note, boys and girls, I input N1, N2. These two values I sent to a method called as GCD. These are all the actual values. Whatever you feed N1 and N2, the actual values should go to the, okay, the actual values are sent to a method called as what? GCD, where it finds the GCD of two numbers whose answer it will return something. It will return as an integer number that will be stored in result 1. Similarly, integer result 2. What happens is N1 and N2. I send this method called as LCM. It goes and finds out the LCM value, whose value will be returned, that will be stored in R2, which I am going to display right now. Which I am going to display in the main method. What I am going to display? LCM of these two numbers. Should I? What do I do is system dot out dot println GCD of, what I am going to do is I am going to display GCD of N1 and please note, boys and girls, this is where I begin the main method, I end the main method. I divide this program into 3 modules. The first module is main method, where I create the object and input 2 numbers. These 2 numbers I send to GCD. It will find the GCD, that will be returned, that will be stored in R1, the shortest form of result 1. After finishing the GCD, again it comes back. The same number which I have inputted 2 of them will be sent to a third method called as LCM. it finds the LCM of these two numbers. That will be returned, that will be stored as R2. What do I do is GCD of, please note, I am opening and closing. Is it a pair of double quotation? Is it a pair of double quotation? Is it a pair of double quotation? Whenever you open the double quotation, you need to close. So there has to be an even number of double quotation, boys and girls. See, whatever has been given within double quotation will come as it is. GCD of N1, whatever you have given, it will say, it will come. And N2 is. So the number would you give GCD of the first number and second number is R1. Right? Similarly, LCM of N1 and N2 is R2. So I need to send the control to GCD. It will find the greatest common divisor of two numbers, right? That will be stored in R1. Similarly, it will find the LCM of these given two numbers, that will be stored in R2, right? I'll wrap it off. You can continue other two methods. Boys and girls, here is the 1/3 of the program you have done before. The rest of the 2/3 of the program. Please note, let me mark with a different color. This is the method called as GCD. This is the method called as LCM. Already we have done the main method. Am I right? Okay. What do I do is, the value of first value will be stored in A and second value will be stored in B. Let's presume where the first input, what you are going to give is 67. So what I am going to give here 67 and second value I am going to give 23. Right? What I am going to give 67 and 23. Right, now let's find out what is the GCD of these two numbers. Right, GCD of these two numbers. Let's find out. The first value is 67. If you want, I can take a input, process, output table. Right. In other words, I am going to keep the track of all the variables. What variable do I use it? A. What is the next variable I use it? B. What is the next variable I use it? Numerator. Next variable I use it? Denominator. And the next variable is HCF, which is the output. Please note, boys and girls, what value are you setting from the main method? 67 will be there in A. 23 will be there in B. HCF value will be 0. Numerator and denominators, NUM is shortest form of numerator and DEN is shortest form of denominator. If you declare them, you will be using them. If you don't declare anything, by default it's 0. Find out, is A is greater than B? Is 67 is greater than 23? If it is true, it happens. Your numerator becomes what? A value will be in numerator. What the numerator value is? A will be in numerator 67. Your B will be in denominator 23. Comes down. Here is a while loop. As long as the denominator is more than 1, you will be repeating the steps over and again. The moment the denominator is less than 1, it will comes out of it. It will comes out of it. What the denominator is right now? 23. Is 23 is more than 1? Yes. Numerator mod denominator. When you divide 67 divided by 2. Sorry, 67 divided by 23. 67 divided by 23. When you do it, what happens is 46. When it is 3, it will be 69, right? So what happens is, what will be the denominator is? The denominator is 21. What is the value of R as? R is the shortest form of remainder. What is the remainder value will be? 21. Is 21 is equal to 0? No, it comes down. What happens is denominator becomes numerator, remainder becomes denominator. So denominator becomes what? Numerator. Your numerator becomes what? 23. And your remainder becomes denominator. Again, when you close this, it goes up here. What is the R value? What is the denominator value? Is 21. Is 21 is more than 1? S. Again, numerator is what? 23 divided by 21. 23 divided by 21 means the remainder will be 2. 21 ones are 21, remainder is. So your modulus function will give you remainder. What is the remainder value is right now? 2. 21 goes off. Right now it is 2. Right? What is the remainder value is 2. 2 and 0 are they equal? No. Comes down. So the denominator becomes numerator. So this becomes 21. What's the remainder is? 2. It becomes 2. These steps will be keep repeated till you get denominator is more than 1. What is that? When you go again here, what the denominator value is 2. Is 2 is greater than what? Yes. Numerator modulus denominator. 21 modulus 2. The remainder will be 1. The remainder will be 1. 1 and 0 are the same. 1 and 0 are the same? No. So denominator becomes what? Numerator. This becomes 2. What the remainder becomes 1. Again it goes up. What's your remainder is 1. Is 1 is greater than 1? No. It comes out of this while no. Denominator is what? 1. 1 and 1 are they equal? Yes. So what's your HCF is? HCF was 0. Now it becomes 1. Return HCF. Return HCF means from this GCD method it will return and it will go and store in R1 and display that R1. Okay. So the GCD of 67 and 23 would be what? 1. You give different, you know to be 67 and 23, you give any number as you like. So this programming statement will do the job. Now let's go to the third part of the program, which is first part is main method, second part is GCD, now third part is LCM. Let's go to the LCM part of it. Here is, instead of using, here I use a variable A and B, here I use X and Y. Two values you input it, from the main method, and that will be the actual parameter. And what are the formal parameters? Let me use different color, blue color let me use, or green color. So what is the variable I use it? X. What is the next variable I use it? Y. Then what do I use it? LCM. Followed by there is no A and B here. You have X, Y, LCM. Let's see that. Then N value. Let's see that. How does this drive run the program? Now, let me take the same numbers. Let's say LCM of 18 and 3, right? Any number you can give. 18 and 3. 18 value will be X, 3 value will be Y. Come down. What the LCM value is? Nothing has been told. By default it will be 0. What is the x value is? 18. Is 18 is less than 0? No. Is 3 is less than 0? No. Here I begin. I use here the while loop. Here I use the for loop. Care needs to be taken. For loop should have 3 fragments. The first is initial value. No checking is done till the optimal value of n it will go. Then what is the next value is? N plus plus. Every time it increases by 1. What is the n value will be right now? 1. N value will be right now 1. Right? 1 is divisible by both. What number did he give here? What number did he give here? N of x and n mod y. Is n is divisible by both the numbers. If so, then you say as the LCM. What is the n value is right now? 1. 1 mod. What the x value is? 18. 18 mod 1. Sorry, here is a mistake. X mod n and y mod n. X mod n and y mod n. 18 is divisible by 1 and 3 is divisible by 1. If they are so, it becomes what? Your LCM becomes 1. No. I repeat again. Boys and girls, today I am going to drive in the program. The third part of the program is called as LCM, right? The first parameter will be stored in X and second parameter will be stored in Y. And the third variable, the resultant, the final LCM will be stored here, right? The final LCM will be stored here. Now let's keep a tab of all the variables, input, process, output table we call. Let's see what are the variable I use it. I use a variable called as X. I use a variable called as Y. I use a variable called as LCM. Then I use a variable called as L. Should I take a note of it? Okay. Imagine you give the value of 15 and you give the value of, let's say, 12. Right? What is the LCM of 15 and 12? We shall see here. Any value for that you please try. X value will be 15, Y value will be 12, LCM value as nothing has been told, by default it will be 0. Is 15 is less than 0? No. Is 12 is less than 0? No, it comes down. Please note, boys and girls, the difference between this loop and this loop is this. This is a while loop. As long as denominator is more than 1, you keep doing this job. Here, I start the value as 1. Every time I increase it 1. A first statement should have 3 fragments. The first is called as initialization. The second one is called as final value. And third part is increment or decrement. In this case, it's increment. If you look at closely, I left it blank. Semicolon, semicolon. Okay, the second portion I am not doing it. Every first statement should have 3 fragments. Initial value, final value, incremental value. Most of the time we use the incremental value. If demand may be, we can use the decremental value. Comes up. What do I do is n value and x value. Are they divisors I find out. What is that n value is? N value is 1. 1 mod 12 will be what? 12. And 1 mod x value is 15. 1 mod 15 will be 15. 15 and 0 are they same? Are they equal? No. What is the n value is? What is the n value is? 1. N value is 1. 1 mod 12. 1 mod 12 will be 12. 12 and 0 are the same? No. It comes down. Next n, sorry. N value will be 2. N value will be 2. Mod value will be how much? 15. 2 mod 15 will be how much? 1. 1 and 0 are the same? No. What is the y value is? Y value is 12. 12 mod 2 will be 0. 0 and 0 are the same? Yes. False and true. Why the n value is 2? 2 mod, what is the x value is? 15. 2 mod 15 will be 15. 15 and 0 are the same? No. Comes down. Next n, sorry. N value will be 3. 3 mod 12 will be 3 mod 12 will be how much? 12. 12 and 0 are the same? No. Then it will be 4. 4 mod 12 will be how much? 12. 12 and 0 are the same? No. It will be keep doing it. Then n value will be how much? 12. 12 mod 12 will be how much? 0. In this case, what happens is 15 mod 12 will be 12 mod 15 will be 0. Now it will be, what happens is, it will be keep checking 1, 2, 3, 4, 5. It will be endlessly going till it reaches the value of whichever the greater value. It will go up to 15. It will go up to 15. Right? What happens is, whenever both the conditions, this is condition number 1 and this is condition number 2. If both conditions get satisfied, that n value will be stored in LCM, then it will return. then it will return. In this case, what happens is, here in your textbook, what example have they given? They given 60, 67 and 23. 67 and 23 means it will be keep finding out. At last it will find the value of LCM, which will be 1541. Here it will find. You have to try. You have to try. Keep a track of the tab of the input process output table. Right? It will find the LCM. That LCM, the n value will be stored in LCM and return that LCM. Please note. It's not a void function, it's an integer function. A function called as LCM, which is a public function which will return integer value as you are doing now. A function called as GCB, which is a public function. What does it return? It returns an integer value. This, when you say return LCM, means that gets stored in your back in main method in a variable called as R2, which is the shortest form of result2. Display the LCM of 15 and 12, it will display this, right? So this is the second program. Okay, tomorrow's class I am going to do 2 more programs. Instead of dropping 2 programs in one, which becomes 3 boards, so I will do tiny programs. At least another 5 to 6 programs we will do it. Number problems and string problems. Then we shall go to the class 12 syllabus. I repeat again. These are all the exercises we are doing. Just revise our programming knowledge which we have acquired in the class 9, 10 and 11. Right? These are all the very important problems. One need to practice it. Okay, boys and girls? Kindly practice the programming in your notebook. Copy down this program. I will check physically all the programs which have been done in the virtual classes should be there in your notebook. Okay, take care. Bye-bye. Keep practicing the program, boys and girls.